For a washing machine to do its job, it needs energy, materials, and data, things like dirty clothes, clean water, soap, and power. These are called inputs as they go into the machine. Every technological system has inputs. The washing machine, like any other technological system, has outputs as well. Outputs are whatever the washing machine outputs, like clean clothes, but also dirty water, noise, pollution, etc. Outputs can also be energy, material, or data. Here is a fun activity for your students. Ask them to name the inputs and outputs of a desktop computer. In this case, the keyboard would be an input and the screen an output. Speakers would be outputs as well, but the microphone an input, and so on. Robots can be described in a similar way. They have inputs and outputs, and these define what the robot is capable of doing. Let's have an even closer look. We'll start with inputs. These are usually electronic or electromechanical devices that can convert a physical quantity to voltage. The robot's controller, which is the brains of the robot, uses this voltage reading when running a program. Don't worry, we will explain this further in the next session when we talk sensors. We will see that with more sensors, there is more the robot can see around it. In this session, we will focus on the outputs. These define what the robot can do. With more outputs, there are more things a robot can do. Robot outputs, in most cases, are used for motion. Robots, unlike washing machines, are more versatile in their ability to move. Whether they are along an assembly line or cleaning the house, the ability to move is a must if you want to be a respectable member of the robotics community. Motion is almost always acquired using electrical motors. The motors convert electrical energy into kinetic energy, meaning they move, or in most cases, they spin. Here is another fun activity. Ask your students to find out how many motors they have at home. Motors are hidden in almost every household appliance. A washing machine has two motors, one to spin the drum and another to pump water. Shaving machines, food processors, the microwave, these all have motors as well. Can you guess how many motors I counted at my home? Any guesses? Excellent. Whoa, 150 is a lot. Okay, I counted 31 motors, and I probably missed a couple. So, using inputs and outputs, robots can sense their environment and act accordingly. This is where we come into play as the programmers. We determine what action the robot will take for different situations. This is what makes a robot stand out from other technological systems, like our washing machine. Robots are programmable to accomplish completely different tasks, making them so much more versatile. While a washing machine will always clean clothes, the same robot can be used to assemble a car or make frozen yogurt. Let's summarize what we know so far. Robots are problem solvers. They have sensors and motors to help them sense the environment and take appropriate actions. When designing a robot, We need to understand the problem so we can equip the robot with the relevant inputs and outputs. Then we can use code to tell the robot what to do. With Coder-Z, writing programs is super easy. Let's see how easy it would be to instruct our virtual robot to take action.